Hi, my name is Emily Provenzano, and this is my final presentation on my opinions of the state of cognitive science and where it's going. In 1973, Alan Newell wrote a paper where he was supposed to tie all of the papers of a symposium together. He comments that while most individual papers in this collection had good data and a logical theory to back it, there was a major problem when you tried to tie them all together. He comments on the fact that although the experiments are done well, they seem to ask the wrong questions, and the answers they achieve don't really seem to get us any closer to the answers to the right questions. He discusses how really they just discover phenomena, which, although real, aren't necessarily the answers to the bigger questions of psychology. For example, he argues that when we try to discover how these phenomena come about, we just end up with binaries, or two opposing theories that scientists spend way too much time arguing nitpicky differences between. I agree with Newell, and I feel like we often saw this pattern in the readings we did for this class. As an example of that, I'm going to talk a little bit about the debate on conceptualization. Cognitive scientists want to understand how we think. In order to do that, they think it's important to understand how we sort information we know into concepts, and how those concepts are organized in the brain. The phenomenon that they study is often language and word choice, operating under the assumption that it's the best way for us to look into the brain because it's how we choose to tell others how we think. Therefore, the study of conceptualization further branches into subfields. Some scientists study the use of metaphor in language, arguing between Lakoff and Johnson's structured conceptual metaphor theory and Faulkner and Turner's conceptual integration theory, ultimately deciding that the answer is probably somewhere in the middle. The study of conceptualization doesn't stop there. Some scientists branched into trying to figure out how these concepts are organized in the brain, once again in opposition forms. Some scientists believe that the brain creates an internal representation of the outside world, while some believe that the outside world is all the representation we need. Some believe that the brain operates on an abstract level, using symbols, while others believe that it can only possibly understand the concepts in the combination of the sensory inputs in which it experienced them. The answer to this problem is most likely a somewhere in the middle answer, but there isn't just one proposed answer. However, the problem isn't which one of these theories is correct. The problem is, why does it matter which one is correct? Will that actually get us closer to finding out the ultimate question of how do people think? It's easy to just answer yes. Scientists have to do this every day to feel that what they're doing is worth it. And in some ways, they are correct. Each time a sub-question gets crossed off as solved, it gets us closer and closer to being able to answer the ultimate questions. However, I think the harder answer is no. Even if we can get two groups of scientists who study these phenomena as their livelihoods, and all the other scientists who study similar things but have opinions on these debates as well, all on the same page to answer one binary opposition, there are still a million more phenomena to explore and a million more binaries to solve. Sometimes by trying to solve one, even more binaries come up, dragging the problem further and further down the rabbit hole. So how are we supposed to solve this problem? I think the only way we can actually begin to put these smaller questions into a larger picture is to look at it objectively. While scientists believe they are objective and often drawn to science for its objectivity, they still do have their life's work, finances, families, futures, and legacies all riding on the results they get and the theories that come up to explain them. I don't think that's objective at all. Some scientists are smart enough to be able to say that they were wrong sometimes, or that their data could be explained by the opposing theory as well, but often every scientist has a bias in one direction or the other. What is supposed to solve this is peer review. However, even the reviewers have their own biases. They're scientists, and due to the integrated nature of research, in order for them to be right about their own theory, this theory or that theory must also be correct. So what's the solution? Personally, I think there are a couple untapped reservoirs of objectivity that could be used to do a metadata analysis of each subfield. First, I think that researchers should be asked to do more reviews of other fields. The hard part about this is that researchers are busy people with their own work and might not have time to learn a whole other field that they have no stakes in order to write a better, more objective review. That leads me to option number 2. This job may already exist, but I think there should be some people who do not participate in research themselves, but have a job of reading every single discovery that comes out for a field and making sure that they could all mesh together into a larger theory. While they might have a lot of the same debates that the scientists who perform the research have now, they should have an added objectivity of not having their life's work on the line, and might be more likely to see things from both sides. The third option I can see is using students better, especially in classes where they do overviews of subfields, which I know I took quite a few of as an undergrad, and this one is similar, just more in depth. These students have freshly heard many arguments from over decades in the span of a couple weeks. With all this information fresh in their minds, they should be able to start to detect some discrepancies that may have been lost due to time. Therefore, to answer the question of are we doomed to continually find more phenomena to theorize about in binaries until we fall deeper and deeper into the rabbit hole, or is there hope of eventually answering the larger questions of cognitive science and science in general, I don't know. But I choose to stay hopeful and put my faith in the scientific community to notice these problems and do something and attempt to address them, or build good enough computers to do that for us, whichever comes first. Thank you.